The universe is a puzzling place. It's very big, quite old, and rather empty. Most of space just contains radiation whizzing around, and most of the matter that we see is clumped into relatively small structures such as galaxies. But where did this small amount of matter come from? Is its existence a statistical accident? Or is it an inevitable consequence of nature's underlying physical laws? Back when the universe was about 1 second old, it was as hot and dense as the interior of the sun, and protons and neutrons were cooked up to provide the lighter elements we find today. So where did the protons and neutrons come from? In the 1960s, the Russian physicist Andrei Sakharov explained how this might have happened. Experiments had shown that in collisions of particles, their energy transforms into particles and antiparticles. It was found that every type of particle has a mirror antiparticle with identical mass, but an opposite electric charge. And when particle and antiparticle meet, they destroy each other, leaving nothing but radiation. Now, Sakharov assumed that during the Big Bang, a gigantic amount of energy transformed half into matter and half into antimatter. But if the forces governing particles and antiparticles were exactly the same, they would have completely destroyed each other as the universe expanded, leaving nothing but radiation. But here comes the clue. Experiments at particle accelerators have found that some particles and antiparticles behave slightly differently, and Sakharov explained how these small differences might have led to a small excess of matter particles, which would have survived to make galaxies, and us. Today, we still do not know for sure if Sakharov's theory was correct, and what caused the balance to tip in favor of our type of matter. To figure it out, we need more experimental information. One of the experiments at CERN's Large Hadron Collider will address this question by studying differences between a so-called B quark and its antiparticle, the anti-B quark. I find it fascinating to see how experiments in the laboratory could contribute in a decisive way to solving one of the great mysteries of the universe, the absence of antimatter.